Okay, so in this video we're going to discuss the metric micrometer. As you can see here, I have one set up. If you look down at this bottom piece right here, it says 0 to 25 millimeters. That's representing how large this micrometer can read. So that is your range, and you will find that on an imperial and a metric micrometer. It will always tell you how big and how small that micrometer can read to. So before we get into the reading, I want to go over the certain components of a micrometer. So this piece right here, that is called an anvil. The anvil is a precision piece of metal that's cut and it does not move. This piece right here is called the spindle. The spindle is the component that actually moves. We have the space in between here, and we are measuring the outside diameter of a component. So as I open up the micrometer, this space would get bigger, the spindle moves back, or it can move forward and get closer and closer to the anvil. This piece here is the frame. This is the only part of the micrometer that you need to be holding or should be holding when you are measuring something. This is heat treated or heat protected, so the heat that comes from your hand will not affect the readings of the component you are trying to measure. Again, it also will always have that range in there. So this one being 0 to 25 millimeters, and I made a reading of, let's say, 32 millimeters, I know I've done something wrong because my range is out. So I go back and recheck my reading. This piece right here is called a lockout. So when you've measured something, what you can do is turn on this lock and it holds the measurement in place. So I can take the component out from in between the two components or in between the two pieces here, and then I can make my measurement. This piece right here is called the sleeve. It is the stationary numbers that this piece here, my thimble, or sometimes called a barrel, will start to uncover numbers. This last piece right here is called a ratchet. So similar to your ratchets that you use to tighten or loosen bolts, it will actually make a clicking noise when you've reached the tightness of the micrometer. So what we're talking about, or what I'm talking about there, is if I'm measuring the outside diameter of this marker here, I've gone in between this gap. What happens is, if I just take the thimble and turn the thimble, I can potentially distort or damage the component that I'm measuring. The ratchet has a specified amount of tension on it. So if I take this off here, I unlock it, you can see that I can turn back and forth, but as I get closer and closer to the anvil, you can use the thimble until you're almost to the spot where you need to, or almost touching the component. So you can see I have a very small gap there. Then I turn to my ratchet. You'll actually hear the audible clicking, and you've reached as tight as it can go. Then we can make that lock. You can use the thimble to spread it back out if you need to, whatever you are measuring. Again, the thimble or the ratchet is what you want to get into practice with. So what I'm going to do is read this micrometer. Again, I have my range, so I know how much I can actually go through. The thimble here, when it rotates, it's uncovering numbers on our sleeve. On this specific one, you will notice I have a 0 and a 5. Each one of those lines in between represent 1 whole millimeter. So what you look for is how many lines are exposed by the thimble. So as I count across the top, I have a 5 and I have one more line on top of that. Nothing else is visible. So what I need to add is 6 millimeters. My next reading is off this bottom portion here. Again, the thimble rotates and uncovers lines on the bottom. Each one of these lines represents half a millimeter. When we look really, really close, you can actually see 0, and then in between the 0 and the 1 is where that bottom line lines up. So that's that half millimeter. So looking at my micrometer here, I have the 6, and I do have one of those 1/2 millimeter lines available. So I write my 0.5 millimeters. I put the 0 just to keep your decimal places as you are slowly adding things in. Your last measurement on a metric micrometer is the thimble. So this piece right here is your guideline. Whatever your guideline or your center line lines up on the thimble. So you can see I have 10, 11, 12, 13. The 14 line here matches up with my center line. If it was slightly past the 14 and not to the 15, I still go back and use the 14. But my 14 line matches up with my guideline. If you look down at the frame here, it's showing you that each one of these lines represents 0.01 of a millimeter. So if I'm up to 14, that represents 1, 4. Now ultimately all we have to do is add this your measurements up. So you have 6.64 millimeters on this micrometer.